Okay, folks, units 2 and 3, lesson 16, solutions to linear equations. What is a solution to a linear equation? Well, we know linear equations make lines when you graph them. So isn't it kind of odd to ask to solve a line? How would you do that, right? The idea with the solution to a linear equation is that it's just a point on that line, okay? So we find a point on the line. Now, there's just really one way to do this. You plug your x and y in. Well, there's one way to do it if you don't have a graph, I suppose. You plug x or y, sometimes both. But for our purposes, we're only going to work with one variable today. Work with subbing in for one variable today. Plug x or y into y equals mx plus b. And then solve for the remaining variable. Good work, Dave. Solve for the remaining variable, like that. Okay, so if we have this linear equation here, this y equals negative 1/5 x plus 8, what is the value of y when x has a value of 10? Well, we're looking for y, and we know that x is 10. Okay, so what we're going to do is we're going to take this 10, we're going to plug it in for that x. So it's going to become y equals negative 1/5. The x is fully going to go away, and we're going to replace it with 10. Okay, now negative 1/5 times 10 is the same thing as 10 divided by negative 5, which is going to be a negative 2. Okay, if you want to plug this into a calculator, you would do this. You would say, let's just do parentheses. Yeah, we'll do negative 1 divided by 5 in parentheses, and then we'll just do 10 parentheses as well. Negative 1/5, actually, hold on. Negative 1 divided by 5, parentheses, divided by 10. There we go. Times 10. Gosh, sorry, guys. Ha! Negative 1 divided by 5 times 10. There we go. Negative 2. Negative 2 plus 8 is going to get us to 6. So that's our y value right here. Technically, that's our solution, but we can summarize it a bit by saying that the point, man, I cannot write today, on the line is going to be an x value of 10 and a y value of 6. Okay. What is the value of x when y is the value of negative 3? So you can see that we have kind of flip-flopped the x and y here. So we know that y is negative 3, and we are looking for x. So rather than plugging it in for the x, we'll plug it in for the y. So we've got negative 3 equals negative 1/5 x plus 8. We'll subtract 8 on both sides, because that's the inverse operation of addition, is subtraction. And negative 11 equals negative 1/5 x. This is the same thing as saying negative 11 equals negative x over 5. So we'll multiply by negative 5 on both sides. They cancel out here, and that's going to get us an x value of 55. So the point on the line is going to be 55, negative 3. Okay. Now, we use this, well, let's just graph it first. So we've got this graph in the back. Negative 1/5 x plus 8. Our y-intercept is 8, so we're going to start here. And then we're going to go down 1 and right 5 for our slope. 1, 2, 3, 4, 5. Right. We'll do another one. Goes out to 10. And then we'll reverse it. There. And there. Cool. Use protractor, please. Or a ruler to give yourself a straight line when you graph lines all the time. Your math teachers will appreciate it. Now, this point here, we just found that point, right? We just found that 10, 6 is on this line, okay? But we don't have 55 and negative 3 on here, okay? But this just goes to show you that we can see that x equals 10 is on the graph because y equals 6. Why is it useful to graph the answer? Sorry, why is it useful? We can double check our work. What am I trying to say here? We can double check our work using a second representation. You're using a different representation. But it gets a little more useful when we talk about when we have the point that's not on the graph, because our graph is too small. We can see that when y is -3, the point is not on the graph. Why is it useful to use an equation when we don't have a graph? Because it allows us to solve equations, solve linear equations without a graph, or without the need of a graph. Just makes us more versatile as mathematicians, without the need for a graph. Right? This is just like we talked about slope formula the other day. You can use a slope, or you can use a graph to find slope, but if you don't have one and you just have 2 points, then you can use slope formula, right? Just makes us better at dealing with these types of problems, to be able to not be limited to only using one strategy. So that's the idea there.